99% of the Earth's history is hidden from us. How did colossal creatures traverse continents that no longer exist? The answer lies buried within the fossil record itself. And we must reconstruct environments from 200 million years ago. But trackways reveal more than just a single dinosaur's path. But concentrations of specific species suggest organized movement patterns. Now that we understand the basic evidence, let's explore causation. The Earth itself was constantly rearranging its geography. But climate fluctuations created powerful selective pressures for movement. Periods of intense global warmth pushed fauna toward cooler poles. Herbivores, dependent on massive food sources, initiated these grand treks. Their sheer biomass necessitated constant searches for forage. The lead animals were likely experienced navigators, sensing changes. But did they use magnetic navigation cues, similar to modern avians? Geological features served as permanent, visible landmarks. Water sources dictated the corridors of movement across dry zones. But even smaller dinosaurs participated in these longitudinal journeys. Paleobotany confirms shifts in vegetation zones over time. Predators followed their prey, creating an ecological relay race. The opening rifts posed temporary, yet massive, barriers. Temporary land bridges offered crucial crossing opportunities. Sea level changes dictated accessibility to new territories. Isotopic analysis reveals dietary shifts indicative of new regions. This dispersal explains biogeographic patterns we see today. Altitude presented a significant physiological barrier to overcome. An adaptation to lower oxygen required circulatory system evolution. The success of migration ensured species survival against localized extinction. A refuge was sought in sheltered microclimates during harsh phases. Different groups migrated at different speeds and scales. Diurnal cycles influenced resting periods and energy conservation. We study growth rings to estimate the duration of these movements. These arrows represent established, multi-generational travel paths. Ocean currents indirectly affected terrestrial weather patterns globally. Catastrophic events could initiate rapid, desperate migrations. That is, survivors were forced toward unexplored, potentially safer peripheries. But nesting grounds were often established near the terminus of a route. But young learned migratory routes through mimicry and guidance. The transition zones required rapid behavioral and physical adjustment. A sensory input confirmed the success of the long, arduous journey. The planet's internal dynamo provided a constant, reliable reference. A desertification acted as a slow, inexorable push factor. Obstacles were overcome not by speed, but by sheer persistence. The fossil record captures only moments of these long expeditions. As continents separated, once connected populations fragmented. And this isolation drove the evolution of regional dinosaur lineages. But pollen analysis shows the flora migrants encountered. For water flow regimes changed, demanding new riparian strategies. But each step in the migration was a high-stakes calculation for survival. And the sheer ecological diversity of the Mesozoic was the driver. Survivors carried the scars of their long journeys with them. Global temperature shifts directly dictated habitable zones. The competition intensified as resources became concentrated in smaller areas. Pheromonal trails likely marked safe paths for following generations. Not all migrations succeeded, many ended abruptly in disaster. Evidence of sudden burial tells us exactly where migrations failed. Each fossil is a data point in a planetary scale puzzle. Comparing finds across hemispheres confirms ancient land connectivity. Gene flow across temporary corridors shaped future diversity. But the age of migration ultimately gave way to continental isolation. These colossal journeys remind us that movement defines life itself.